This is Plant-Based Briefing. How accurate are measures of nutrient density? From Colin Campbell at nutritionstudies.org. And I'm Marian Erickson, and this is the curated content plant-based podcast where I narrate a variety of articles related to plant-based and vegan living with permission in about 10 minutes or less every weekday. And today's article is from the Colin Campbell Center for Nutrition Studies. It was established to extend the impact of Dr. Campbell's life-changing research findings. He's the co-author of the best-selling book, The China Study, as well as the book Whole, Rethinking the Science of Nutrition, from which this article is an excerpt. So now let's get to today's plant-based briefing. How accurate are measures of nutrient density? A selection from Colin Campbell's Whole, Rethinking the Science of Nutrition at nutritionstudies.org. The following excerpt comes from Dr. Campbell's book, Whole, Rethinking the Science of Nutrition, released 10 years ago. It explores how reductionist measures in nutrition fail to account for the variability of natural processes. To learn more about reductionism and its alternative, holism, read our webpage on Whole, linked here. Wrench number 1, the wisdom of our bodies. Are you sitting down? Because I need to explain something that almost no one acknowledges about nutrition. There is almost no direct relationship between the amount of a nutrient consumed at a meal and the amount that actually reaches its main site of action in the body, what is called its bioavailability. If, for example, I consume 100 milligrams of vitamin C at one meal and 500 milligrams at a second meal, this does not mean that the second meal leads to 5 times as much vitamin C reaching the tissue where it works. Does this sound like bad news? To reductionists, it certainly does. It means that we can never know exactly how much of a nutrient to ingest because we can't predict how much of it will be utilized. Uncertainty, a reductionist's worst nightmare. Actually, this is very good news. The reason we can't predict how much of a nutrient will be absorbed and utilized by the body is that, within limits, it depends on what the body needs at that moment. Isn't that amazing? In more scientific language, the proportion of a nutrient that is digested, absorbed, and provided to various tissues and the cells in those tissues is mostly dependent on the body's need for that nutrient at that moment in time. This need is constantly sensed by the body and controlled by a variety of mechanisms that operate at various stages of the pathway, from nutrient ingestion to nutrient utilization. The body reigns supreme in choosing which nutrients it uses and which it discards unmetabolized. The pathway taken by a nutrient often branches further and branches further again, leading the nutrient through a maze of reactions that is far more complex and unpredictable than the simple linear model of reductionism would suggest. The proportion of ingested beta-carotene that is actually converted into its most common metabolite, retinol, or vitamin A, can vary as much as 8-fold. The proportion converted also decreases with increasing doses of beta-carotene, thus keeping the absolute amounts that are absorbed about the same. The percentage of calcium absorbed can vary by at least 2-fold. The higher the calcium intake, the lower the proportion absorbed into the blood, ensuring adequate calcium for the body and no more. Iron bioavailability can vary anywhere from 3-fold to as much as 19-fold. The same holds true for virtually every nutrient and related chemical. In brief, the relationship between amount consumed and amount used for virtually all nutrients is not a linear relationship. Although many professionals know this, few fully appreciate the significance of this complexity. It means nutrient databases are not nearly as useful as one might think. It also means reductionist supplementation with large doses of discrete nutrients does not guarantee the utilization of those nutrients. In fact, our digestive processes are so complex and dynamic that superdosing with a single nutrient all but guarantees an imbalance of some other nutrients, as we'll see in wrench number 3 later in this chapter. Wrench number 2, the variability of foods. Not knowing how much of a given nutrient will be used by the body is only part of our uncertainty. The nutrient content of the foods we eat themselves varies far more than most of us realize. Look at the research just on one antioxidant vitamin, beta-carotene, and/or its related carotenoids. Beta-carotene content in different samples of the same food is known to vary 3 to 19-fold, although it may be up to 40-fold or more, as was reported for peaches. That's right, you could hold a peach in each hand, and the one in your right hand could easily contain 40 times more beta-carotene than the one in your left, depending on things like season, soil, storage, processing, and even the original location of the fruit on the tree. And beta-carotene is far from the only example. The relatively stable calcium content of 4 kinds of cooked mature beans, black, kidney, navy, and pinto, ranges 2.7-fold, from 46 to 126 milligrams per cup. The variation in food nutrient content and the variation in nutrient absorption and utilization by the body compound each other. A simple exercise might help to make the point. Suppose the amount of beta-carotene in a carrot varies about 4-fold, and the amount of this uncertain proportion that is then absorbed across the intestinal wall into the bloodstream varies another 2-fold. That means that the amount of beta-carotene theoretically delivered to the bloodstream from any given carrot on any given day might range as much as 8-fold. These are huge but uncertain variations, and whether these ranges are 2 or 40-fold, the ultimate message is the same. With the consumption of any particular food at any particular moment, we cannot know with any precision how much of any nutrient is actually available to our bodies, or how much our bodies actually use. Wrench number 3, the complexity of nutrient interactions. But wait, there's more uncertainty. You may be surprised to learn that the 3 nutrients mentioned above can modify one's other activities. Calcium decreases iron bioavailability by as much as 400%, while carotenoids like beta-carotene increase iron absorption by as much as 300%. Theoretically, in comparing a high-calcium, low-carotenoid diet with a low-calcium, high-carotenoid diet, we might see an 800 to 1200% difference in iron absorption. But even if this theoretical variation were only 100 to 200%, this is still huge. For some nutrients, tissue concentrations varying by more than 10 to 20% can mean serious bad news. Interactions among individual nutrients in food are substantial and dynamic and have major practical implications. An outstanding review by researchers Karen Kabina and David McMurray at Texas A&M University summarized the published effects of a large number of nutrients on the exceptionally complex immune system. Nutrient pairs that were found to influence each other and in turn to influence components of the immune system include vitamin E and selenium, vitamin E and vitamin C, vitamin E and vitamin A, and vitamin A and vitamin D. The mineral magnesium influences the effects of iron, manganese, vitamin E, potassium, calcium, phosphorus, and sodium, and through them the activities of hundreds of enzymes that process them. Copper interacts with iron, zinc, molybdenum, and selenium to affect the immune system. Dietary protein exerts different effects on zinc, and vitamin A and dietary fat affect each other's ability to influence the development of experimentally created cancer. Even closely related chemicals within the same chemical class can greatly influence each other. For example, various fatty acids affect the immune system activities of other fatty acids. The effect of polyunsaturated fats found in plant oils on breast cancer, for example, is greatly modified by the amount of total and saturated fat in the diet. The fact that magnesium has already been shown to be an essential part of the function of more than 300 enzymes speaks volumes about the possibilities for the almost unlimited nutrient interactions. The effects of these interactions on drug metabolizing enzymes and on the immune system also apply to other complex systems, such as the hormonal, acid-base balance, and neurological systems. The evidence cited here represents only an infinitesimally small fraction of the total number of interactions operating every moment in our bodies. Clearly, the common belief that we can investigate the effects of a single nutrient or drug, unmindful of the potential modifications by other chemical factors, is foolhardy. This evidence should also make us extremely hesitant to megadose on nutrients isolated from whole foods. Our bodies have evolved to eat whole foods and can therefore deal with the combinations and interactions of nutrients contained in those whole foods. Give a body 10,000 milligrams of vitamin C, however, and all bets are off. You just listened to How Accurate Are Measures of Nutrient Density, a selection from T. Colin Campbell's Whole, Rethinking the Science of Nutrition by T. Colin Campbell at nutritionstudies.org. And I'm Marian Erickson, your host, and this is so fascinating because I was raised with advertisements and marketing bombarding me about specific supplements and nutrients and vitamins and orange powder to replace your fiber intake. And it's interesting that we really know so little about the way our bodies work and metabolize and how everything works together. This stuff is so fascinating. Anyway, please share this episode with anyone who might benefit, and thanks for listening.